Welcome. Is this on? Yeah, great. Howdy, I'm Jeffrey Snover, and you'll notice the lack of Don Jones. Don Jones couldn't make it today. He had an ear infection, and his doctor won't allow him to travel. So I will, however, take a second and point out that a bunch of the content of this, so this is Don Jones here, so if those are missing him. But Don has written a number of great books, and a lot of the content from today's talk came from his book around learning PowerShell, learn PowerShell tool making in a month of lunches. So that was the basis for a lot of today's talk. Now that said, with him gone, I decided to change things up quite a bit. And so hopefully you'll like it. And in particular, one of the big differences is I've decided to go quite a bit deeper on some topics. You know, a lot of times we do these advanced topics, and it's kind of like this race across the topics. You know, we're going to talk about functions and modules and remoting and blah, 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 blah. And we go so quick that sometimes we don't go as deep. And so I thought it would be fun to go a little bit deeper on some topics. Now, let me gauge the audience. How many of you are just beginning to use PowerShell? Okay, so you guys are going to find some challenging aspects to this, right? This is the advanced session. So, and then how many of you are advanced? Okay, good, good. Well, hopefully there'll be stuff there for you too. I think there will be. Someone talked about, when are people going to learn all the things that are in PowerShell version 4? I said, my friend, people still haven't figured out all the things in PowerShell version 1. So hopefully I'll show you some things here today and that are available in PowerShell version 1. By and large, everything I'm going to show you is available in PowerShell 2 and PowerShell 3. There's very little, I don't think anything I'm showing here that's dependent upon PowerShell version 4. The talk after this, desired state configuration, is a PowerShell v4 talk. If you haven't heard about that, I think you want to come see that. That's going to be very exciting. I'm giving that with Kenneth Hansen. So with that, again, I'm Jeffrey Snover, distinguished engineer. I had invented PowerShell, and that turned out to work out pretty well. I got distinguished engineer for that and eventually became lead architect for Windows Server. That was during the Windows Server 2012 phase, and that worked out pretty well because now I'm the lead architect for both Windows Server and the System Center Data Center products. And I think you've seen as I've done well, so has PowerShell. You see PowerShell more and more throughout all of our products. It's better integrating things, and the increased investment in PowerShell just continues to grow, both within Windows and Microsoft and outside of it. So investing in learning PowerShell, good deal, right? And I've heard from a lot of people about how it has helped transform their careers. So again, mainly this is going to be largely demo-driven. There you go. With that, let's talk about commandlets. So in PowerShell, we had in mind this the admin development model, right? The admin development model was we want an environment that people can figure the system out, right? That you walk up to a keyboard and you start figuring it out. In fact, there's a great story. I think it was a year or two ago, they did this survey of expert Unix administrators versus beginner Unix administrators. And it was so funny because they came to the same conclusion that a similar study over 30 years ago had reached. And it went as follows. Say, take beginners, take experts, give them a written test. Guess what? Very little difference in performance. Very little difference in performance. So what the heck's with that? I'm paying these Unix expert guys all this money and there's little difference between them and a beginner? Indeed. Then you put them in front of a system and you had them do things. And there was a huge difference in performance, right? And the experts were just great. And so the conclusion was that what made a Unix expert an expert wasn't the facts that he had in his head. It was his ability to sit in front of a machine and figure things out and very, very quickly. Well, that's the world that we try to create with PowerShell, a world where you sit there and you create things and figure it out, right? That's why the essence of PowerShell is an essence of exploration and figuring things out. However, after you figure things out, often you find, hey, I do the same thing over and over again, and I want to codify it, okay? And what we have is this graduated series of sophistication and formalism for your encoding. And we call these things commandlets. Okay, so let's show you. Okay, by the way, in the back, top row, can you read this? Yeah? Okay, good. Good. Okay. By the way, this is a pretty precarious thing. If you see me fall over and if I pass out, Thomas here is going to take over the class. Okay, so if you see me teetering, mention something. Okay, so again, now you can start off, it's an interactive world, right? So you can do things as simple as hello world, right? Oh, it just works. You want to be a little more formal, use the formal. It's right, hello, right, output, hello world. Okay, now if you want to be a little more formal, you create this thing called a function. And here, let's do it here. Okay, so now I've got this function. And now what I can do is I can just write test hello world, happy. By the way, this is the formal way to do it. I'm going to show you formal and the informal, right? The reality is when I write things, I end up with this nice formal world, but often when I'm just hacking around, I just call my functions T, because T is really easy to type, right? So you do that, you define it, and then you just say, oh, shoot, darn, oh, come back. Oh, undo. Well, there you go. That's why I did this. Control C. And now you just type T. Right? So nice and simple. Okay, so great. Now let's talk about this function. Didn't do very much, didn't get very much. Okay, now what you're going to learn is that PowerShell is all about figuring out how to get the engine to work for you, how to get Microsoft to do all the work for you instead of you having to do it. So if I say, help T, it's not a whole lot there. A little bit, but not very much. And if I try and do syntax or IntelliSense, there's nothing. There's nothing to be done. And now watch what happens. Now we're going to make it a little bit more formal. We're going to grab 2 lines, and it says, hey, first is that this thing can have parameters, the param block, and then I declare a commandlet binding. That's the only thing I've done. And what happens is this is your way to tell the system, to tell the PowerShell engine, hey, get off your butt and do some work for me. I said, okay. So we do that. Okay, so now T just works, right? Same as before, so big deal. What's the difference? Oh, well, what's the difference? Remember, we said help T. Okay, oh, well, now you have these common parameters. Well, what's that about? Well, one way to find out is, there's 2 ways to find out. One is you can say T dash, and you have IntelliSense. And so look at this. Now all of a sudden, just by putting those 2 things, I got verbose, debug, error action, warning action, all these things. Okay? So let me give you an example here. Wait. So you just type T, just works. Now I can see, let's say $X, $X. There is no value. I can say T minus output variable X. Now I say $X, hello world. Output variable is something that the engine provides for you. You're able to say, hey, run this command and take all the output and put it in a variable called X. Now, how did that happen? Just by putting that commandlet in that parameter, you told the system to turn it into a commandlet, and you get all that for free. Now, there's another way that you can find this out, and there is get command T. Okay? Now, I don't know if you ever explored the get command. It's really quite amazing. Right? So here, we'll take this, CLS, get command, and do format list star. There's a ton of great stuff there. Okay? And in particular, there's this thing called parameters. Now, one of the new things we did in version 3 is like so useful, was this notion of an array operator. Okay? So now what I can do here is I can say, get command T, I run this as a sub-expression, and now what I can do is I can say dot parameters, and I can get all the parameters. I don't know if you've ever seen that. So now we have this array operator. By the way, when in trouble, fear, or doubt, use processes. Processes are one of the most useful things to explore the system in PowerShell with, right? So let me give you an example. $x equals get process. Right, so if I just say $x, you see the whole enchilada. But now I can say $x dot process name. And I get all the process names. Okay, so that's this dot operator. Okay, and so it works across multiple things. And this can cascade. You can say dot modules, and you get all the modules, and then dot file name. You get all the file names. So anyway, that's an array operator, which produces an array, which then do an array operator on. The dot thing is well worth exploring. But let me go back. So this was all about, I put in this commandlet binding and parameter, and that's your way of asking the engine, hey, do a bunch of stuff for me. Okay? And so that's what we showed. Next, let's have some fun. So here, I got a rich version of my script. Okay, it's no longer a simple script, it's a more complex script. Okay, let me show you what we've done. So first off, again, I'm going to make it T because I'm a lousy typist. We have the commandlet binding and the parameter, but notice here we say, hey, this supports should process, and on the parameters, we have a parameter, to, and a bunch of glop here. We'll talk about that in a second. And then we have this begin, process, and end block. So you see, PowerShell is all about pipelining, okay? It's about pipelining objects. And when you pipeline objects, this begin block, you have the optional begin, process, and end blocks. Begin gets called before you process any objects. End gets processed called after you process all the objects, and process gets called for each object, one per. Okay? So what we're going to do is this block here is going to get called, one per, and what we're going to do is first to say, hey, should I process this thing? And if so, I'm going to say hello, and then to. Okay? So now we've parameterized our hello world, right? Pretty rich hello world. Okay? So now I'll say T minus 2, TechEd, Madrid. Okay, so here in that begin block, we had that let's get friendly. So let's get friendly. This process block got called here. Okay, and then when we were done, we had enough of that. That got typed out there. Okay, now there I typed it on the command line. But I mentioned it's all about pipelining. PowerShell is all about power. The power of PowerShell comes from objects and pipeline. So what we did was we took a look at this too, and we said, hey, this parameter, I want to be able to pipeline the value. Value comes from the pipeline. So we say true. Now what that means is that when you put this in a pipeline, PowerShell is going to see objects coming to it, and it's going to say, what do I do with those objects? And what we're going to look for is we look through the parameters and we say, are any of the parameters declared to accept the value from the pipeline? Because if so, we grab it and we give it to them. Okay? It's as simple as that. So now what I can do is I can say, Todd, Carol, Ann. Right, by the way, so that's just an array. And I pipe that to T. Oh, I screwed that up. Let's try that. Let's try that again. Let's say John, Carl, Mary, pipe to T. Okay? So there we see the beginning. Then we have this block called once for each name, Carl, Mary, and John. And then when we're done, we say enough of that. Okay? Now, the reason why it failed before was because I wasn't watching. See all this red here? What's that about? And the answer is up here. one of the benefits of PowerShell is, again, you tell it to do work on your behalf. And one of the things you can do is validation of data. And so what we did was we had a validation script attribute that we put in here. And we said was, hey, I want to validate that the value is not in Ann, Carol, or Todd. Okay, so we said any names except those. Okay, so, by the way, so I could say, well, let's do it again. Let's add Todd to the middle of here. And you see, it worked for John, worked for Carl, barfed on Todd, and then worked on Mary. Okay? And by the way, now this is where some of those other parameters come up that are interesting. Remember, we had IntelliSense. There were a bunch of things there. There were things like error action and error variable. So let's say error variable. Error variable. Let's just say Q and error action. Well, that's interesting. What's there? What can I do? Well, look, I can continue, I can ignore, I can inquire, silently continue, or stop. So let's try inquire, because I don't know what that does. And it goes and runs, and look here. It comes across the error, and it inquires, what should I do about this? And we'll say, yeah, keep going. Throws the error, and continues on. You see Mary and then that. And then remember, I said the error variable to be Q. So now $Q, $Q, oh, I got that wrong. But now let's do this. Let's do stop. And here, notice, I don't have the end. I have the start, got John, Carl, but when it comes to Todd, there's an error that occurs, and what happens is, because I told it to stop, it goes in and stops. And this is the point. When you write code, often it's very difficult to understand what should happen when there's an error. I mean, you might know, but you might be wrong. And so in general, what PowerShell does is it says, let the person who's running the code decide what to do when an error occurs. Again, all you did was to declare something, a commandlet binding, and we provided that functionality for you. When the program produces an error, we'll assign it to error action. We'll look at this error action to determine what to do. So lots of fun stuff. By the way, I also mentioned here, I missed something here, mandatory. So mandatory says that, hey, you've got to give me this. So if I just type, so again, if I just type T, it says, hey, there's a mandatory data, you've got to give it to me. So I'll say Carol, Carol Ann, and it just works. So this is the trick of PowerShell, is to figure out how you can make it do work for you. Now, if you want to find out all the things you can do here, documentation, of course, is the right way to do it, or IntelliSense. Validate, IntelliSense, and you'll see a bunch of our things. You can validate the count, the length, etc. So you could say, hey, I validate the length. What did I say? I don't know what the validate length is. Now, one of the ways we do this stuff is, I tell you what, I can never remember that stuff. I just have a bad memory. So here's a trick. Bring up a new window and Control-J. Control-J is IntelliSense, or sorry, scriptlets, or snippets. And one of the snippets, right, so you have like the syntax for do, while, or for, or loop, and we have commandlet snippets, okay? And so here, I just go here, and it's got all the interesting stuff in that snippet. And what I do is I put it in a temp file, I see what I look for, and then I grab it. Like, oh, okay, mandatory, value from pipeline by property name versus arguments, position, null, validate set. Oh, alias, there's a fun one. So I'll come back here. Where'd I go? Come back here. And I'll say, hey, sometimes I want it to be 2, but I could say the alias of this parameter is, alias is recipient. I'm sure that's wrong. Recipient. Oh, Lord. Okay, so remember I said I'm a bad typist? I'm a bad speller? Well, you thought I was joking, didn't you? Well, okay, so why is that interesting, right? Well, no, seriously, I'm just horrible at this stuff. So I could say minus 2, foo, right? That works. But or I could say minus recipient. Oh, what happened? Did I do that wrong? Oh, I didn't dot it? Sorry, there you go. Well, I'm not sure why it's not showing up in IntelliSense. It should have. Anyway, the point I wanted to make was that in PowerShell, you only need to specify enough of the variable, the parameter. You don't have to specify the whole thing. Did you have an insight? I thought I did. Okay, well, let's try it again. Do the whole thing. F8. There you go. T. Yeah, no, I did. So that looks like a bug. I might be doing something wrong.
Parameter of aliases, you need to go back at the end with dash. So you trigger it once and then go back again. Then probably we get.
Okay, that sounds like a bug to me. That's okay. I got what I wanted to show you. Okay, so does that make sense? So again, formalization. You can be as formal or informal as you like. Now, one thing I missed here was this whole thing, hey, why do we have this should process? Okay, so in PowerShell, we make this promise to our users, right? Here's the deal, right? I once talked to an admin, and he said, every now and again, I'm about to go do something, I'm about to hit carriage return, and I realize if I got this wrong, right, I could get fired. Right? Like the systems are going to be out, bad things are going to happen. Muffy and Buffy are not going to be able to go to college. It's just going to be bad. And so we say well, that's a crummy world. So we ask you and we do it ourselves, whenever you're going to do something that has a side effect on the system, to always make sure you do it in a safe way. And the way you do it in a safe way is before you do something, like here you're just going to echo hello world, so that's safe. But if you were going to have something that had a side effect on the system, deleting a process, deleting a user, shutting something down, what you do is you call this PS commandlet should process. You say what you're going to do to and what you're going to do to it to. So the target and the action. And basically that's going to return true or false. Okay, and if it's true, do it, and if it's false, it doesn't, right? Now this is turns out I got a patent on this thing. This is awesome. This is like the most valuable one line of code you can make, because with it you can do the following things. So So T minus 2 Joe and minus what if. Okay, now look at that. It says, what if? Performing the operation greet on target Joanne, and notice nothing happens, right? We do the begin, we do the process, but we didn't do things. So what happens is when you type minus what if, right? When you back up here, when you take commandlet binding and you say supports should process equals true, we add 3 additional parameters to the commandlet. What if, confirm, and verbose. So what if says, hey, when you do this, notice you're not processing what if, you just call should process. We map that to, if they've said minus what if, we print this out and return false. Now, what happens if you type verbose? And the answer is, we're going to print this out and return true. Okay, so we print it out, and then look, it returns true, so the action occurs. Now what happens if you type minus confirm? And the answer is we ask, hey, do you want to do this? Yes or no? And if you type no, we return false. And if you type yes, we return true, and we do it. So pretty cool stuff. Again, this is all about how you leverage the system to give you all the benefits and the behaviors. Now, at some point, you might say, well, why? Why do you do all that? Like hey, back here, I had this validation script, right? And I said, hey, the recipients can't be Ann, Carol, or Todd. I just freaking hate those people. So don't greet those people. They're jerks, right? So you could have said, well, why should I use your validation script? Why don't I just check for that and write my own error message, right? So, and indeed, you could. Don't do it, right? Because here's the difference. So again, we'll say T minus 2 Todd. Okay, there. We produced the error message, right? You didn't. We produced the error message. And it's a well-formed message. Now, imagine that we're here in Spain. I wrote myself a little script called using culture. Oh, sorry. Where am I? Okay, I'll dot source that. I've got a script here using culture. Using culture. Oh. It's horrible. Not recognized. What am I doing? Yeah, right. Dot. Okay, there we go. I don't know. So I'm going to specify a culture, and then I give a script block of what I want to do. And what did I say? It was T minus 2 Todd. And notice, it's in Spanish. Yeah. So this is the difference, right? So the point is that when you use the PowerShell engine, we do the localization. A couple things. One is it's a standardized message, right? And so what happens is as users use the system, they see these things, they read it for the first time, and then after that they recognize the message. They don't have to read it again. If we all do this test and write error messages, I guarantee there's going to be as many error messages as there are people in this room, leading to an inconsistent world for the users, and I guarantee none of us are going to translate it into Spanish. Or if you're Spanish, you're not going to translate it into English. But we do that for you. Okay? Okay, so now let's talk about IntelliSense. Okay, so here I got a simple script. Okay, and what this script does is a test service. Okay, and all it does is it gets a service. Okay, so test service. I get all the services. Now, watch what happens when I say, I'd like to say where something. Control space, nothing. No IntelliSense. Now notice the difference. If I say get process pipe to where, and do this, I get IntelliSense. Oh, I want those where the company, not like Microsoft. Or table, watch this. Company name. Okay, so notice, I did that right, company. Okay, so that worked, but when I did it with services, get or test service, pipe to where, nothing. And why is that? And the answer is because we have no idea what test service is going to reply, right? What's it going to output? We have no idea. So what you do is you tell us. That's what output type is about. You go and you say, hey, this service, I'm going to tell you what objects it outputs. I'm going to tell you that it outputs a system, service processor, service controller. By the way, how could you have told that? And the answer is test service pipe to get member. And it's right there. That's the thing. You declare it to be the output type, and now test service pipe to where Ta-da. And you get IntelliSense. So that's what output type's all about. Where name, like, a star, pipe to format table, minus auto size, property, name. There you go. Okay, so IntelliSense. So again, the theme I'm trying to strike here is figure out how to make PowerShell work for you. Instead of you doing all the hard work, why would you do the hard work? Figure out how to make PowerShell do the hard work for you. By declaring things with an output type, that enables PowerShell to add all this rich capabilities for you, right? So again, imagine you've got a script. Let's just do this now. Now I'm going to say, again, not writing any code, right? Not running any code at this point. $foo equals test service, right? Now I've not run any code. But because of that, I can say $foo dot, and I can get IntelliSense, right? So that's because you've given us the information required to do it, the output type. Okay, last thing I want to highlight here is our rights. So in PowerShell, we have, it is a rich set of pipes. So what happens is, when you type A, pipe to B, pipe to C, right? It looks like your traditional Unix command. Let me tell you, nothing could be farther from the truth. This is very sophisticated technology. In fact, underneath the wires, what's happening is there's this object flow engine. Okay, like if there's data flow engines, this is an object flow engine. So what happens is, you see A, pipe to B, pipe to C, we map those symbols to compute elements. We then create this directed graph of those compute elements and wire a series of object streams amongst them and the host. And then we pass control to the first one. It runs until it emits some objects. Those objects then sequence the other ones, which then run until they generate objects, which then sequence other ones. Now, why do you care about any of that? Well, there's two reasons. One is it's cool. I mean, it's just cool technology, and it gives you amazing capabilities. But the second is that this is why we're able to layer GUIs on top of PowerShell. Because if I was creating a process like in the Unix world, I don't know, if you ever see, Unix does not layer all the GUIs on top of command lines. I mean, it happens here and there. And the best example is, in fact, IBM's SMIDI, which is quite good, but it's slow as sin. I mean, it's just hideously slow. And why? Because every time they want to do something, they got to launch processes. Here we don't, right? All these compute elements can run, they can run out of process if you want, or they can all run in process and be blindingly fast. So that's the point of that. Now, I said, you type these things and you run the code, and there are various object streams that come out of them. What are those object streams? And there's your answer, okay? So the main object stream, the one that most people understand, is this output stream. That's the pipeline. But then you write things to an error stream. You can write things to a debug stream. We have a progress stream. Get rid of this one. We have a host. A host is not a stream. This is important. In general, Don Jones is pretty hardcore on this. He says, every time you call write host, a puppy dies, right? So don't write to out host. Now the reason for that is out host, we have different hosts. PowerShell is an engine, it's a DLL that then gets coupled to different hosts. And those hosts are different. Anyway, anytime you type something to the host, you can't process it anymore. Like again, here's the difference. If I had done CLS, if I do write output hello, right? I can pipe that to %$_to lower. And make it lowercase, right? But if I do write host, that shouldn't have worked. Oh, what happened there? Oh, what happened there was It did work. It was just a little nuanced. So when I say write host, it goes directly to the host and writes that value, and then nothing got passed on to the second part of the pipeline, so you can't process it. That's why, one, it's in uppercase, and then two, it didn't get lowercase. So anyway, so don't write things to write host. And then there's a warning stream and a verbose stream, okay? So let's run all this stuff. Take this. And test. Okay, there's my progress stream. Now look at this. Look, I got output. I got my error. Output, error. No debug. You saw the progress. You see the host. And there's a warning. But there's no verbose. So there's no debug and no verbose. So what's going on with that? Right? And the answer is, these are things that you have to ask for. So if I test minus debug minus verbose, yes, then you get it. There's the debug and the verbose. Okay? Yeah? Now, the other thing I want to point out here is the warning action. So, warning action. Okay, so associated with each one of these streams, the idea is that when I get an object, I've got this object flow engine, I run it, I get an object out of it. The engine then does a bunch of stuff with it. It's not a dumb pipeline. It's a very, very smart pipeline. And in particular, what it does is it says, one, where's it going to, and what do I need to do to get it there? Right? So sometimes it just hands it to it, and that's fine. Sometimes it says, oh, this guy needs something like this, and I have something like this. What do I have to do to give him what he needs? Do I have to convert the object? Do I have to construct a new object? Do I have to shard it in some way or shred it in some way to cast it to that? We do all that work. That's work that we do that you don't have to do. And the second is, it allows the user to specify things to do as part of that processing. So one of those things is like actions. So by default, when you send something on the warning pipe, it goes out the warning stream. In general, that's silent. If you say minus warning, it gets surfaced to the user, but you can also specify an action. So you can say, hey, I would like to, wrong screen, I would like to stop. Okay, so notice now, right, I did a warning and then verbose. But here what I'm going to say is, if you ever get a warning, just go ahead and stop. Here, this is asking me about debug, so I can continue. And warning. And notice I don't get the verbose. It got to that warning, and then you were able to control it, saying, when you get a warning, stop. And we tell you that's what happened. Okay, so there you go, commandlets. There is a ton to do with commandlets. I think I missed something. So this PS commandlet. Remember I showed you that $PS commandlet should process. What's that? And that's a thing, that's a variable that's only available to you inside of a process or inside of a script. Now, so you might say, well, okay, well, what is that thing? Let's go explore PS prompt. And you'll notice PS commandlet. There's nothing there, right? You know, there's no there, right? And why? Because it only exists when you're running a function. But it's really important. So how do you do with this? Okay, and one answer is, I'll say, inquire. This is where inquire gets fun. So now I'm going to run things. I'm going to say, hey, when you get to inquire a warning, inquire what to do next. Okay, so let's just continue with this. I get to the warning. It says, hey, what do you want to do? My options are yes, yes to all, halt, or suspend. Suspend. So I suspend. Now what's happened? Look, my progress bar is still up. So what's the suspend? And what's happened is I've now got a nested prompt. Look here, right? I can do whatever I want. 2 plus 2, right? That all works. I've suspended the operation of the function with an interactive prompt. Now I can do anything. So why is that useful? Remember, I said $PS commandlet only exists when you're running the function. So now, $ps commandlet exists. When I type it to get member, it tells me everything. Okay, so the technique here was to use a suspension of the script. I did it through having a warning. I said, hey, inquire, then suspend. Now I've got this nested prompt, and it's showing me all this wonderful stuff. Now look here, get provider location, get dynamic parameters, get resolved provider path. I mean, there's just crazy, lots and lots of stuff. Oh, look here, write debug, error, etc. Turns out those commandlets are all just ways to call these functions. Okay, they're a simpler way to do it. Okay, and then there's a ton of properties. Hey, how did I get invoked? What's the job manager? What's my invocation? Right, so $ps commandlet, right? There's a ton of very interesting stuff there. In particular, .myInvocation. Lots of fascinating stuff. So this is something you want to go explore. There's a ton of stuff there. But notice something's a little bit strange here. Okay, notice the prompt, right? PS. Now how's that different than the previous prompt, right? And the answer is it's the same. So isn't that a little goofy? Like you're in this nested thing, but you're not there, you know, like how do you know, right? Well, here's a tip. Remember, this is an advanced course, right? So $, oh here, let's do this. So you all know about drives, right? Variable drive. Everybody know about the variable drive? Dir variable. Okay, that's a pretty cool drive. So it shows you all the variables. So one of the questions is, well, what are the variables associated with a prompt? And look here, nested prompt level. That's interesting. So now let's do an exit. I then finish this. And let's take a look at that again. 0, 1. So whenever there's a nested prompt, we increment this thing. So what that says is, hey, why don't I say function prompt if $nested prompt level greater than 0. We'll say $nested prompt level PS space else PS space. Okay. Okay, so look, didn't change anything. But now if I run this again, and I do a suspend, badonk. See, now it says 1. Okay, there you go. Lots of fun. And by the way, one of the things I'm sure, my goal was not for everybody to be able to walk out, like things I hope you achieve, that you walk out of this class knowing $nested prompt level. That's not the goal. What I'm really trying to teach you, though, is that there is a ton. All the stuff that I've shown you here is existed in PowerShell version 1. There's an incredible amount to it. And so what we want you to do is if you're an advanced guy, what you want to do is you want to learn the techniques to figure out how to go explore the system, because there's a lot there. And why is that interesting? Because with a little bit of work on your part, you can make PowerShell just dance. Make it do all the hard work for you. Okay? And then again, when I exit, my prompt goes back to normal. There you go. That was commandlets. That took longer than the original one did. I hope you enjoyed that. Okay, so next, let's see, so commandlets. There you go. First up, commandlet. Okay, next, jobs. Everything that I've shown you here has been running synchronously. Jobs are a way of running things asynchronously. Okay, now there are lots of different types of jobs, right? There are lots of different ways to run things asynchronously. And what you're going to see here with jobs is a pattern that we use a lot in PowerShell. Now, the pattern is that Well, again, it all comes back to trying to maximize your effectivity, right? Give you maximum power and maximum effectiveness. So what that means is, give me the power to do what I want to do, and then hide all the crap from me, okay? So let's be specific. There are lots of different ways to create a job, but once the job is created, there's a uniform way in PowerShell to deal with all the jobs. Okay? So you learn that uniform way once, and then you learn the domain-specific way to create jobs each time there's a new way. So let me get concrete. And then the other point I want to make here is in PowerShell version 3, we added scheduled jobs. So in the past, anybody ever try to use Task Scheduler with PowerShell? It's kind of a pain in the butt, right? Didn't quite work well. Now that's a fully supported scenario. Okay? So let's show you some details. Okay, so first, let's show you get command start job. Okay, star dash job. There you go. So get job, receive job, remove, resume, stop, suspend, wait. Those are all the same. Start job is just one of the many ways to start a job. Okay, so let me be concrete. So I can say, well, here, you can do get parameter. You get command minus parameter name as job. So when another command performs a function, you can say minus as job. That's the standard syntax for doing it. So all of these are functions which can run synchronously, or you can specify minus as job. Okay, so let me give you an example. Where's one? Get WMI object. So I can say get WMI object Win32 BIOS, and it just works. Somebody's got a nice ringtone. Okay. Is that a call to prayers that the demo will work? I could use that. So, or you could say minus as job, and it runs in the background as a job. Okay? Later we'll go retrieve that. Now, alternatively, one of the things was I could say start job, and there what happens is you just give a script block, anything you want, like get process star SS, and it runs in the background as a job. What were some of the other things here? See. None of these are interesting. We'll keep those. Now, what I want to point out here is that this is a WMI job, so these are both jobs. I say get job, get job, and I get them both the same way. The job type, this is a WMI job, this is a background job. They're both completed, they both have more data and tells you what it is. Now let's say I wanted to receive the results of those jobs. How would I do it? And the answer is the same way. Receive job, and give an ID too. Now what I'm going to do is I'm going to say keep, I'll explain that later, and I get that, or ID 4, and I get the results. Okay, using the same syntax, I was able to get the results from two different types of jobs. Okay, now remember, they're completely different functions using different engines, but they behave the same way. Keep is a way to say, give me the results, but keep them where they are too. And so it allows you to go back and get the results again and again and again. Okay, and then if you just receive them, it gets them in a consuming way, so that if I come back, they're gone. If I do this, or we'll do keep, and I consume them, and then they're gone. So get job. Now notice, different types, completed, has more data, is false. That means all the data has been consumed. Now Don gave me some crap. He says, Jeffrey, by the way, you created 2 jobs and they're called 2 and 4. Like, did you forget how to count? Right? And the answer is, no. Here's what happens. With every job, there's a child job. So in fact, if I say get job, we just hide it. Job ID 3, there's a 3, and there's a 5. Okay? So what happens is, okay, now look here. This was that. Okay? Let me make it a little clearer. Imagine I say invoke command minus computer name dot localhost dot and I'm going to say host name. Okay, so this is going to run host name minus edge job. Okay, so this is job ID 6. In fact, what's happened is this is a parent job. Actually, you know what? I did the wrong thing. That was bad. I'll do it this way. I'll say sleep minus seconds get random for get date. Okay, just get a little randomness to this. Okay, so now what happens is I've got 3 tasks running against the same machine. They're going to wait some random amount of time and then get the date. Okay, now this is one job. But what happens is that job is in fact a parent job with a number of children jobs. So I'll show you that. I'll say $J equals get job ID 10, $J, $J, type to format list star. By the way, this is one of the examples. Like, don't fall into complacency by just emitting something and taking the default output. When we do these default outputs, because in general the world is incredibly rich, and if we gave you all that richness, you would just be overwhelmed and you wouldn't be able to get anything done. So we look at these objects and we say, yeah, these are the things you're going to need the most. However, there's a ton more to it, and you can go explore, and you should, because there's a lot there that you might end up deciding is interesting to you. So notice, when I do a format list star, there's a ton of stuff, including finished state, and look here, child jobs, job 11, 12, and 13. Okay, look, tells you when it began and when it ended, etc. Okay, so now, $, what was it, $J, right? So that was the controlling, no, that's not right. Yeah, is that it? Yeah, $. Did I do that right? Yeah, okay, so $J is 10. If I say receive, by the way, do you notice what I'm doing here? Again, I'm not making it up. I'm just a really lousy typist. So you can use wildcards. You can use wildcards lots of different places. So I can remember as I before E except after C, although by the time I've done that, I've already typed the wrong thing. It's just horrible. So I just start REC star job and then tab, and it works for me. So I can say $J, and what I'm going to do is keep. And what happens here is, okay, so there are my 3 dates. So when I receive the parent job, it acts as a controller to all the children jobs. Okay? So anything I do to that parent, I do to all the children's. Receive, stop, wait. Okay? However, right, I could have said, receive job, what did I say? It was 10. There was 11. I can just get that one, get that individual, 12, 13. You can treat them individually or as a collection, or 10, right? And that's whether you wait, receive, kill, etc. So pretty powerful, crazy, cool stuff. Okay, now, here what I'm going to do is I'm going to start a job. I'm going to sleep for 2 seconds, output 1. I'm going to start a job. That's one thing I'm going to do. And then I'm going to start a job, another job. I'm going to sleep for 5 seconds. I'm going to do 2. And then what I'm going to do is I'm going to say receive that job and type done. Now this is interesting. Watch this. Look, the done happened. I did the receive job, and done happened. Well, where's my output? And the answer is get. Oh, shoot. What did I do? job. They're down here, 13 and 14. So what happened was I ran these things in the background. I did a receive. They weren't ready yet. And so it just gave me every data it had, which was nothing, and then output done. Right? So if I had just waited, right? So $, oh, there it is, $J. If I was just able to wait, right? And so here, that's what wait job's all about. I'm going to wait, and you can specify any that says wait for any of these jobs to be done. Default is all of them, and then I'll receive it. Oh, sorry. So now I do it again, and I get the 1 and 2. Okay? So now let's do this again. Let's have some fun. Let's do it again. So I'm going to do this. Here, let's do it this way. Comment this out. So I'm going to start my 2 jobs, and then very quickly I'm going to wait for any one of them. God damn. I'm just hideous with this keyboard. It's quite scary. That won't work. Thank you. I wait, and look, I only get 1, and then it's done. And if you take a look now, $J, now both of them, 1 has no more data because I already received it, and the other one is completed and done. And so if I do receive job, I get 2. Okay, so that's the notion of being able to receive the jobs. Now, that's all stuff that, in general, whenever we do these as jobs, in general, they're running in the current process, and if that current process terminates, all that job information and data is lost. There's a couple exceptions to that. First, of course, is workflow jobs. You can run workflow jobs in a separate run space, and they will persist across reboots and such. And the other is scheduled jobs. Okay? And so the thing about a scheduled job is that you register them. So I'm going to register a scheduled job, and here's the code I want to do. I want to get the date, I want to get the disk, and I want to output it to a string. And we're just going to give this a name of test 100. Okay? Now, if you were to go into Task Scheduler, you'd find there's a particular channel there for Windows PowerShell, and you'd see this underneath that. Okay? So we have tightly integrated in with the Task Scheduler. Okay? So now I've got this scheduled task, but what am I going to do with it? Right? When do I run it? And the answer is you decide what your triggers are. Right now we've defined the job, but not the triggers. Okay? So here, these are all the things you can do with the scheduled task, right? So there are triggers, there are scheduled jobs, and there are job options. Okay? So let's take a look at the job trigger. Okay? You can run things once, new job trigger once, at a particular date and time. You have random delays and repeat intervals. You can run things daily. You can run things weekly. You can decide to run things at a logon or at a startup. And you can have multiples of these things. So this is how you specify a one-time trigger. I don't know if you've seen this trick, right? So you can say get date, right? But did you realize that you can do math on that thing? Add days, 10. So that's 10 days from now. You can subtract days. You can do that, right? Everybody's seen the famous one. My daughter, if you haven't heard this one, my daughter, when she was a young kid, she was like fixated with Christmas. Like, how many days to Christmas? How many days to Christmas? So I wrote her a script, right? So first is date, time. What is this? 12/25/2013. That's a date time minus get date. And I tell her how many milliseconds it was to Christmas. Okay? No, it's kind of fun. So then the trick is, right, so my family, we live in the States, and my family, my in-laws live in the UK, right? So what you can do is you can say, well, hey, when do I have to send ship presents, right? And so what you can say is you can say add days. Let's see, so it's going to take 7 days in a week. It'll probably take 6 weeks to get there. And then I know, minus. If I want to be late, that's how I do it. Minus. I know that I got to ship them out by November 13th if I want 6 weeks. So crazy powerful stuff. Again, this is one of the things you find as you explore. By the way, so the trick here is explore and then share, right? Because then other people can see the stuff that you do, and that happens to me all the time. Like I'll share something, and then somebody else will come back and they'll say, "Oh, why'd you do it that way? Did you realize you could do it this way?" And even I continue to get taught about how to use the system. So sharing's a great way to improve the world of others and also to improve your world. Anyway, so here what we're doing is we're saying, hey, we're going to have a one-time trigger 1 hour from now. Okay, so that's my trigger. Here's what a weekly trigger looks like. Okay, in fact, we're going to save this off in a variable. A weekly trigger on the days of the week on Friday at 6 p.m., right? So after everybody's gone off for beers. Okay. Then we're going to have a daily trigger, daily at 3 a.m. That's my daily trigger. And then what I do is I'm going to have this register scheduled job, a daily backup. I don't think it's going to, I'm going to register one. It's just creating one. You register it. I'm going to have a trigger, which is the daily trigger. And then here's my script block. Okay, in fact, I probably need to create that file. mkdir c important files. So what this is saying is whenever that daily trigger comes, run this code. Copy all the items from this directory to this backup directory. And notice again what we do here. We do a get date, to file, and we do a recurse and a force. Okay, so we register that job. Yeah? And then we're going to do a weekly backup. And so the weekly backup is triggered on a weekly trigger. And we'll have some script here. And I better create a script there or it'll work. Barf. Yeah, it has to be there or it'll complain. Okay, so now I've created this. I can say, hey, on the weekly report, go run this script. Okay, and then get the scheduled jobs. And there are the 3 things that I set up. Okay, so very nice. And now I can, by the way, so now I can do start PowerShell. Right, bring up a separate process here. This is too small, isn't it? Let me make that bigger for you. I can come here and okay, separate process, I can then get these scheduled jobs. Okay, so these now they're integrated in with the system task scheduler. Okay, and here, if you wanted to find out when things will run, so when you just get the daily backup, right, just shows you this job. If you just run that, it shows you this. You can pipe it to get job trigger, and it shows you what's going to happen. Oh, it's going to run daily at this time. You can get the advanced options. Oh, hey, I want to start if it's on batteries, stop it if it's going on batteries, wake the system up to run it. I mean, you got lots and lots of control. I mean, this is one of the most powerful things we added in version 3 was this integration, this nice deep integration with the scheduler. And then here, so here what I'm saying is I'm going to get the schedule for daily backup and I'm going to set it so that if there's multiple things that run, I want you to queue them and that it requires the network. Okay, so then, and you see that requires network somewhere here. Run without the network is now false. etc. So pretty powerful stuff. And let's see, I don't think I started any. Yeah, there was some setup to this I didn't do. But anyway, so then to get the jobs, it's as simple as receiving the results. So the point about these things, unlike when you tried to integrate in with a task scheduler, typically what you do is you went to task scheduler and you created something and you said, oh, I want to run PowerShell minus command blah blah blah, and then all your data was lost. Right? Well, we integrated in a way that all your data is served, is protected. So as you run this stuff, you can then just say, show me my scheduled jobs, grab one of the jobs, and receive the results, and you get them. So pretty darn powerful stuff. Powerful stuff. So jobs, lots of fun. Okay, now modules. So we talked a lot about commands, but what about modules? Modules are a really simple concept, and it's basically the idea that says it's about a community, right? It's about community, it's about a length of time, right? So it's this next step in formalization, the ability to take code and encapsulate it in a way that I can give to other people, and that if you gave me a piece of code and you gave me a piece of code and they had the same names, that I can somehow manage that I can run both of them without blowing up the system. That's really what modules are about. Now, it turns out modules are, again, one of those things that at the surface are very, very simple, very sort of obvious, but as you pull on that thread, there's just an incredible amount of richness to it, and so I encourage you to pull on the threads, have some fun. So, what is a module? Well, let's make a module. So first is we're going to have a script. Hello world. Oh, thank you. There you go. Hello world. Okay, so we're going to save this. Save as. C TechEd. We're going to call this C TechEd test.ps1. Okay, so this is a script file. Right, and so then I can run test.ps1, happy. Okay, now to make this a module, pretty simple. Test. Oh, yeah. Damn it. We're going to do the following. We're going to say rename item test.ps1 to M. Anybody can add an M there? If you can add an M, you can create a module. That's how you create a module. We now have a module. Okay? Test.import module test.psm1. Okay, there you go. That's a module, right? Get module. See, it's loaded. You got a module. It's a real deal. Okay? So that's as simple. That's literally what a module is. It's a file that has a PSM1 alias to it. Okay? So let's have a little bit more fun with that. By the way, so again, back to my favorite functions. So what I'm going to do is, I always have these aliases, right? So I have this function T, it's going to remove the module, and then it's going to import it again. And in this example, what I'm going to do is, I'm going to create a directory, okay, dir test, and I'm going to put my module in there. Okay, and so now, this is going to be my function. And again, PSM1. Okay. No, I did it wrong. Okay, so this is my function. Let's make sure I did it right. Import module dot test minus verbose. Okay, yeah, so I did it right. So this is my module. And what it does is it has a target, a variable, world. It's got a private helper. And it's going to say hello target. and then test hello just calls the private helper. Okay? Right? So now I've imported that module, and I can say test hello, and it works. Yeah? And notice $target is nothing, right? That's isolation. So imagine I've got a variable $target equals my data that I don't want you to screw with. Okay? Well, I like target. Target's mine, man. Target's mine. Okay? So then again, I import your stuff. I import this. Let's force. Right? And when I run it, test hello. Okay? Now target. You didn't mess with my data. That's the glory of modules, right? It's private. However, is it, right? So notice I got test hello, but also I got private helper. Okay? So I did that, but I didn't really want that to be private. I didn't want that to be public. I wanted that to be private. So what you do is you say export module member, and you tell it what things you want to export. Test hello. That's the only thing I want to do. And when you do that, everything else becomes hidden. So I save it. I run my T function, which exports things and imports things. And notice, even though it says it's bringing private helper and test hello, I run test hello. Yeah? But when I run private helper, F you. What did I do wrong? Oh, thank you. Thank you. That's why it's great. I'm so glad there's some advanced people here. Save my bacon. What they said was you forgot to save it, you dolt. Okay. Oh, what did I do wrong? For else? T. Yeah, okay, that's fine. Okay. So now test hello, happy days, private function, private helper, and it's hidden. What are you talking about, private helper? Now, you want to have some fun? Here's a little trick. We're running out of time, so I'm going to teach you secrets of the PowerShell masters. Okay? So, indeed, right, target can't get at it. The module has hidden that information, right, and only exposed the things that I want, right, that it said I can have access to. So I say get module. I'll say $M equals get module test. So that's the module. You ready for this one? Right? Put your seatbelts on. This is going to be crazy. I can say ampersand $M. Squiggle brackets. What's that going to do? The answer is anything you want to do. Like $target is that. And so what ampersand $squiggle bracket says is, I'm going to run this code in the context of that module. So in the context of that module, it has access to $target. In fact, I can say $target equals and now when I say test hello, oh, you crummy, rep. Did I do that wrong? Well, I did something wrong there. Anyway, you run the code in the context of the module, and we're actually out of time. So the things, let me see if there's anything else I really wanted you to understand about modules. Oh, okay, so the one thing is, in this version, in version 3, we support auto-loading. In the past, you had to explicitly load your modules before you can use them. Now, what happens is, and you'll see this sometimes, when you start PowerShell, the very first time you start PowerShell, sometimes you'll see a delay in loading. What's really going on is, behind the covers, we spawn up an app domain, its own private app domain. And we're off there, and we're loading in all the modules, and we're seeing what commandlets are in each one of those modules. We're bringing them into the system, and then building this big table. That's why when you type get help, you see all the get command or something. You see all the commands, and then when you type something, you get it. So for instance, let me be clear. So I say get module. Okay, so look, well, let's just say $x m1 equals get module. Okay, now if I say like get SMB share, right? Now the SMB code I haven't loaded into this, right? But I can do get SMB share and it works. And why? And I say get module, and it loaded it. Now if you don't believe me, what I'll do is I'll say diff, what I say, $m1 with get module, and you see that here I added, auto-loaded the SMB share. So pretty crazy, powerful stuff. Now, last thing to go before you go, dang, I wish I had more time. This is good stuff. I mentioned, you've given me some code, I love it. You gave me some code, I love it. But you guys didn't coordinate and you used the same names. Urgh! So now what? And the answer is, I can import your code and import your code, and there's this notion of prefix. So when I said import module test, I can say minus prefix oh my, minus verbose. Okay, and look what happened. Test oh my hello. You take that prefix and you put it in front of each one of the noun names. Now, why is this interesting? This is crazy cool. Because imagine you say, hey, I got exchange version X over here and exchange version Y over here. And you can use implicit remoting to import the commandlets from each of those and say, exchange, get, V1 mailbox pipe to set V2 mailbox. And when you do that, the commands will get dispatched over there and then dispatched over there. So there's a lot here. There's a lot to the PowerShell. I really encourage a spirit of exploration and find things. I wanted to go deep on some of the details to, one, highlight some things that we don't often have a chance to do. I hope you enjoyed that. By the way, hope you enjoyed this. Please fill out your forms and let me know whether that worked for you or didn't, whether you prefer more of the general broad overview or you like these deeper drill downs. But I do just want to convey the sense of fun and exploration with the product, and go explore, learn things, share with others, and then tell other people, hey, what about this, what about that? So now, lastly, you should run from here to the next session, the desired state configuration, because that's crazy cool stuff. It's PowerShell version 4, desired state configuration, where you'll see how we use PowerShell to now be able to configure large number of systems in a way that they have their configuration and address the problem of configuration drift. So again, thanks for your time.